Hey students, how you doing today? I hope you're having a good Tuesday evening or a happy Wednesday. Sorry I wasn't in school on Tuesday. So on Tuesday I was going to introduce the why, the how of SOH CAH TOA, like how the triangle ratios work. I will now do a full explanation on it in class on Wednesday. Today, though, we're just going to keep muscling through this, and hopefully, because this is review, stuff you learned in geometry last year, you remember a lot of it. Anyway, so this is SOH CAH TOA Part 2. The difference between yesterday's examples and today's examples is that instead of looking for a side length today, we're going to be looking for an angle. But just like yesterday's problems, you first want to look at the triangle and see which one of these three equations we even want to use. So we label the triangle first. This part of the triangle is opposite the 90-degree angle, so it's the hypotenuse. This side, the 5.4, is opposite of this angle x. If it was adjacent, it would be this side, but we're talking this side, so it's opposite. So opposite, hypotenuse, we're using sine. So our equation is sine of the angle, sine of x, is equal to the opposite, 5.4, divided by 8.3. And what we need to do is to solve this equation for x, we need to get rid of the sine. And opposite of sine, sine inverse. So what we're going to do is we're going to take sine inverse of both sides. Sine inverse of sine of x, that does a canceling out effect, and you get x by itself. On the other side of the equation, you wouldn't want to write it like this. You'd want to write the sine first. And by the way, don't call it sin, call it sine. It's actually spelled S-I-N-E, sine. But when you write it, you always want to write the sine part first. So sine inverse of 5.4 divided by 8.3. This is the exact answer, but then to get your approximation, your calculator does do sine inverse. You can see it right here. It's on the sine button, but it's the little blue one. So second sine. So clear that out. So oops. Make sure you're in degree mode. That your calculator screen says DEG. So second, sine inverse of 5.4 divided by 8.3, close parentheses. And it gave me an answer of approximately 40.587. And because this is an angle measure, we label the answer with some degrees. And that is our decimal approximation of it. All right, let's take a look at example 2 here. I'm looking for this angle M. Oh, they didn't mention that it's a right triangle, which means there's nothing you can do with it. Oh, wait. It is a right triangle. The right angle is right there. Okay. So we look to see what two parts of the triangle it is. This is the hypotenuse, and we don't have the hypotenuse length, so we're just going to have to use these two. This one is next to the angle M, so this one's adjacent. This one is opposite of angle M. So we're looking for an equation that uses the opposite and the adjacent, and that's tangent. So, tangent of the angle M is equal to opposite over adjacent, TOA, 5/8. And just like this problem, the way to get rid of a tangent is to do a tangent inverse of both sides. And when you write it, don't write it 5/8 tan inverse. This is pretty bad math right there. It really should be tan inverse of 5/8. This would be the exact answer. Then you can always put it into your calculator to get the decimal approximation. Tan inverse 5 divided by 8, close, and you get 32 m is approximately 32.005 degrees. One thing I noticed on this one is they didn't give me any units, but when you're looking for an angle measure, you don't need the units. If you looked at it over here, it's 5 feet divided by 8.3 feet. The feet actually canceled out, which left you with an angle measure. The last thing I'd mention here is, let's say that you really hate using sine, or you really hate using cosine, or you hate using tangent. Because they give you 2 of the 3 sides, you could always use a little Pythagorean theorem, figure out the hypotenuse that way, and then you could use cosine or sine. It wouldn't really matter. Let me just quickly do that. This is, let's see, if I go 8 squared plus 5 squared equals w squared, I end up getting that this would be root, let's see, 64 plus 25 is 89. Oops, 25 is 89. So this would be root 89. And now, instead of using, let's say I really wanted to use cosine. So I wouldn't want to use the opposite. I would want to use the adjacent and the hypotenuse. So then I could say that cosine of m equals adjacent 8 over hypotenuse root 89, and then I do that cosine inverse, so m equals cosine inverse of 8 over root 89, which then you're going to get the exact same answer, but I actually like testing this out. I have 8 divided by root 89, so it gives me the decimal of 8 divided by 8 divided by root 89, and then I cosine inverse that, so cosine inverse the answer, and hey, I got 32.005 approximately degrees. So if you have 2 of the 3 sides, you could always find the third side using Pythagorean theorem, and then use cosine and get the same answer. Something you can do. Anyway, everybody, that's all I need to show you today, and we're going to have a fun worksheet to work on in class on Wednesday that just has a ton of these problems, finding both sides and angles. It's called Right Triangle Worksheet. You can find it on my website, and if you can do that worksheet, you're in a pretty good spot right now. Just while I'm thinking about it, our first quiz is going to be on Friday, and it's going to be up through SOH CAH TOA Part 2. Anyway, I hope you had yourselves a great Tuesday, and if you're struggling with the work on Tuesday, on Wednesday morning, come in loaded with lots of questions, because the first thing I'm going to do is ask say, hey, who's got some questions, and answer anything you need to know. Have yourselves a great day, and I'll talk to you soon. Bye-bye.